Question 7, Part A, Part 1. Sketch the graph of y equals 2 cos x for x greater than or equal to 0 and less than or equal to 2 pi. Here is a sketch of the curve y equals 2 times cos x in the domain x between 0 and 2 pi inclusive. Notice that it's the same shape as the curve y equals cos x that has been dilated vertically or stretched vertically by a factor of 2. So the range of y equals 2 cos x is y is greater than or equal to negative 2 and less than or equal to 2. Part 2. On the same set of axes, sketch the graph of y equals 2 cos x minus 1 for x greater than or equal to 0 and less than or equal to 2 pi. The graph of y equals 2 cos x minus 1 is the graph of y equals 2 cos x that has been translated or shifted vertically downward by 1 unit. So the range of the graph of y equals 2 cos x minus 1 is y is greater than or equal to negative 3 and less than or equal to 1. So the graph will pass through these critical points: 0, 1, pi over 2, negative 1, pi, negative 3, 3 pi over 2, negative 1, and 2 pi, 1. Part 3. Find the exact values of the x-coordinates of the points where the graph of y equals 2 cos x minus 1 crosses the x-axis in the domain x greater than or equal to 0 and less than or equal to 2 pi. From the graph of y equals 2 cos x minus 1 that was sketched in part 2, the graph crosses the x-axis between x equals 0 and x equals pi over 2, and also between x equals 3 pi over 2 and x equals 2 pi. So going back to the graph that was sketched in part 2, so this is the graph in particular, and we can see that the points where it crosses the x-axis, we have a crossing point there, and also one there. But the question is asking for the exact value of the points where the graph crosses the x-axis. And at those points, y is equal to 0. So we want to solve the equation 2 cos x minus 1 equals 0. Moving the negative 1 over from the left-hand side to the right-hand side, we get 2 cos x is equal to 1. Then dividing both sides of the equation by 2, we can isolate cos x, and we get cos x is equal to 1 over 2. Now this is a positive ratio, which means that x is an angle in either quadrant 1 or quadrant 4. Let's consider the quadrant 1 angle, or the acute angle. So x is equal to inverse cos of 1 over 2, and we get x equals pi over 3. Considering the quadrant 4 angle, x is equal to 2 pi minus the quadrant 1 angle, so 2 pi minus pi over 3, and we get x is equal to 5 pi over 3. Therefore, the solution is x equals pi over 3, or x equals 5 pi over 3 radians.